Hello everyone and welcome back to my channel. Today we're going to compare the speed performance of a traditional VBA for loop versus the evaluate method of a worksheet. And for this demo I've created a very simple dataset, but it contains 300,000 rows and 2 columns with some random numbers. And the idea is to keep the example very simple. So what we're going to do is we're going to sum the numbers in columns A and B in column C. So if we do this manually, obviously this will be A2 plus B2. And then we can write in column D some if function. So if the number is greater than, let's say, 1000, then we can write large number, else small. So let's first do this with a traditional for loop in VBA. And I'm going to insert a module and write a VBA for loop. This is going to be the name of my subroutine, and first I would like to declare an object variable for the worksheet and then set this to this workbook.worksheets sheet 1. And I will also need two variables to first find the last row and one more that I will use in the for loop. And the last row will be worksheet.cells rows.count, 1 and Excel up that row. And now we can write a for loop. So for I equals 2 to last row, next I. And first, let's see the sum of the two numbers. So worksheet.cells on row I and column 3 dot value equals worksheet.cells on row I, comma 1 dot value plus worksheet.cells on row I and comma column 2 dot value. This will be the sum. And then large versus small number. So we can write if worksheet.cells I, comma 3 dot value is greater than, let's say, 1000, then and if worksheet.cells I, comma 4 dot value equals large, else worksheet.cells I, comma 4 dot value equals small. And before running this subroutine, it's good also to measure how much time it will take for this to run. So I can declare a variable here t, which will be of type double. And in the beginning of the subroutine, we can use the timer function. And then at the end of the subroutine, we can write debug.print and use timer minus t. But in order to see exactly how many seconds and milliseconds it takes, we can wrap this in the format function and format this to this format. And maybe we can also concatenate this with the string for next loop. And now I'm gonna click run and let's see how much time it takes for this very simple subroutine to run. So I'm gonna click run and let's see the time in the immediate window. All right, it's 12 seconds. And that already is kind of slow for 300,000 rows. So I'm gonna copy the entire subroutine because most of it is going to be the same. And let's try to do this using the VBA worksheet evaluate method. So almost everything will be the same. It's just that we're not going to use any loops. And I will change here in the immediate window that this is going to be evaluate method. uncomment it for now. I will uncomment it once the script is ready. Let's remove these two columns. And what I would like to do is to create some dynamic ranges here. So I'm going to declare a few variables for this. So the first one I will call range A, because this is going to be for all cells between A2 and A, whatever the last row is. And then range B. And then I'm gonna change the convention a little bit. So I will call this range sum as range, and range maybe label as range, just to avoid some mistake. And now I can set range A to be equal to worksheet dot range all the cells from A2 to A, and we can concatenate this with the last row variable. And just to prove that this works, we can select it. So if I click run, and if I scroll here to the end, to the bottom of the data, then it seems that the range has been declared correctly. So I can copy this line 3 times and change it a little bit. So this is going to be range B, and this will be all the cells between B2 to B and whatever the last row. This will be range sum, all the cells between C2 and C, whatever the last row is. And this is going to be for the label, and it applies to column D. So now we can use the evaluate method of a worksheet, and we expect that it's going to be way faster than a loop. So I can write here range A dot value, actually not range A dot value, range sum dot value equals worksheet dot evaluate. And here we need to pass a string that represents an Excel formula. So the string will be range A dot address. And since it's a string, we need to concatenate this with the plus symbol and concatenate this with range B dot address. And maybe it's going to be better before running this to print this part, just to see how it looks in the immediate window. So if I click run now, let's see how the string will appear here in the immediate window. So it is this part from A2 to A300,001 plus B2 to B3001. So I think that's correct. So this here is essentially the sum expression. And then the large versus small, we can write range label dot value equals worksheet evaluate. And now we need to create a string that will be like the if function written in a worksheet. So this is a little bit more tricky, but we can write range sum dot, no, actually we need the if function here, so we can write if, and I better use the debug print first, because otherwise I'm sure I'm going to mess it. So I can write debug.print, and this is going to be if. We need to start writing if function and concatenate this with range sum dot address. If I click run now, evaluate. Let me comment this part. Okay, so we have created this string from C2 to C300,001, and here we can concatenate this with the expression if it's greater than 1000, comma, and we can concatenate this with, so if it's greater than 1000, this should be large, else it should be small. And let's see how it looks now. So if I click run, yeah, this is exactly what should be passed to the evaluate function. So pretty much it looks as if you're going to write it in a worksheet. So I can copy this entire expression and paste it here. So this is going to be range label equals worksheet evaluate, and pass it here. And now we can click run, and let me uncomment the debug print method in order to see exactly how much time will this take. So let's click run, and it takes 0.5 seconds. So it's obviously way faster than loop. And I think this is simply because this part essentially, I believe, under the hood calls Excel's engine, in this case 300,000 times, whereas here everything happens at once. Of course, a quick note, the evaluate method only works when a logic can be expressed as an Excel formula. Like if we had to implement some complex algorithm or multi-conditional logic that isn't very formula friendly, then I think evaluate likely wouldn't work well. So thanks for watching. That's going to be it for today. If you have any questions, please drop them in the comments and I'll reply as fast as I can. And I'll see you in the next one.